Hello everyone and welcome back. Continuing with the previous video, Introduction to DBMS, let us see in this video the characteristics of DBMS. As I mentioned in the previous video, before DBMS, we were using the file system approach. In traditional file systems, data was stored in files. Now, for example, if I have one user, say the accounts department, who keeps track of the student fees and their dues, this user just needs the student roll number, student name, the fees paid by the students as well as any dues. And if I have another user, say the exam department, who keeps track of the grades received by the students, that is, it can have student roll number, student name, course, and the grades received by that student in a particular course. Here both the users are interested in data about students, but they have to maintain different files because both have different interests. The accounts department is only interested in the fee details, whereas the exam department is only interested to know about the grades received by the student in each course. So since both have different interests, they cannot have a common file and hence have to maintain different files. As we can see here, the student details as the student roll number and the student name is being repeated in both the files. This leads to redundancy or duplication of data as well as wastage of storage space. Whereas in the DBMS approach, the entire data is stored in a single repository and multiple users can access the data based on their interests. Like for example, data like student roll number, student name, the fees paid, fees due, the grades they have received, etc. can be stored in this single repository and any number of users can access this repository and view whatever data they want. Hence, there is no duplication of data. So that is why we prefer DBMS over the traditional file system approach. Hope you all have understood the difference between the file system approach and the DBMS approach. Now we are going to discuss the main characteristics of DBMS approach. The first one is self-describing nature of a database system. The second characteristic is insulation between programs and data abstraction. The third characteristic of DBMS approach is support of multiple views of the data. And the last characteristic that we are going to discuss would be sharing of data and multi-user transaction processing. Let us look into each of these in detail. The first one, self-describing nature of a database system. A database system not only consists of a database, but it also contains the metadata. We have already seen what a metadata is in the previous video. So it is nothing but the database definition or a complete description of the database. Information like the data type and the constraints, etc. All these information is what we call as metadata, and this information is stored in the DBMS catalog. And this catalog is used by the DBMS software as well as it is used by the database users who wants to know what the structure of the database is. Let us just see an example of a catalog so that you understand better. In the previous video, we have taken this very simple example of a university database that stores student and course information. So based on this very simple example, let us see an example of a catalog. So here we'll see an example of a database catalog where relations or table name along with the number of columns are mentioned. In our example of university database, we have three tables or three relations. The first table that we have is the student table with 4 columns. Then we have the course table with 3 columns. And then finally, the grade report table with 3 columns. And also in our catalog, we can have another table which defines the columns present in each table or in each relation, their data type, and to which table or to which relation that column belongs to. Based on our example of a university database, the column student name has the data type character of size 30 and it belongs to the relation or belongs to student table. Similarly, the column roll number is of integer data type and belongs to student relation or student table. So this is an example of a database catalog where information about the database or a description of the database is stored. Now going back to the characteristic that we were discussing. Now the next point is DBMS software must work equally well with any number of database applications. We can have any number of database applications like, for example, a university database, a library database, or a banking database. As long as the database definition or the metadata is stored in the catalog, DBMS software has to work efficiently or equally well with any number of database applications. Whereas in the traditional file processing, data definition, or what we call as metadata in DBMS, is part of the application programs itself. So they work with only one specific database application because the structure is declared in the program itself. Unlike DBMS, they cannot work with more than one database application. So we have seen the very first characteristic of DBMS approach. Now moving on, the next characteristic of DBMS approach is insulation between programs and data abstraction. In traditional file processing, the structure of data files is embedded in the application programs itself. That is, the structure is within the program. It is not separate. So if there is any change to the structure of data files, it is going to affect the programs. We also need to change the application program. Whereas in the database approach, the structure of data files is stored in the DBMS catalog and it is separate from the access programs. Since the structure is stored separately from the programs, so if there is any change brought to the structure of the data files, it does not affect the programs. And that is called as program data independence. We have already seen an example of a university database. So in that database, we had a student table or a student record. So let us see an internal storage format for that student record. Here we have the data item name or the column name in that record or in that table, the starting position, and the length in characters. In traditional file systems, this structure is present within the programs itself. Now say if I want to add another piece of data, say the date of birth, since the structure is changed, this program will not work and the program has to be changed. Whereas in the database approach, if we want to add a new piece of data, say the date of birth, we can add it without affecting the programs. Since the structure is separate from the programs, we don't have to change the programs. We just have to add this new information in the catalog. So next time a DBMS program refers to the catalog, the new structure will be referred and used. So that is called as a program data independence. Now the characteristic that allows program data independence is called data abstraction. DBMS provides users with conceptual representation of data. That is, it hides the behind-the-scene details or the complicated details that are not of interest to the database user. A data model is a type of data abstraction that provides conceptual representation to the database users in a way that most users can understand. And the data model hides the storage and implementation details from the users. So this is what is insulation between programs and data, or what we call as program data independence. And the characteristic that allows the program data independence is called as data abstraction. The next characteristic of DBMS is support of multiple views of the data. A database has many users, and each of those users will have different needs, or they may require a different view or a different perspective of a database. Like for example, one user will be only interested to know the grades received by the students, while another user will be interested to only know the courses taken by each student. So DBMS will provide only that necessary data that is required for each user. A view, which is a subset of database, that is, it is derived from a main database table. It contains virtual data or data that is not physically stored or that is not explicitly stored. So that is support of multiple views of the data, where DBMS will provide as many views as required by each database user. The next characteristic of DBMS is sharing of data and multi-user transaction processing. As the name suggests, a multi-user DBMS allows multiple users to access the database at the same time. Now, for multiple users to access the database at the same time, DBMS has to provide or it must include concurrency control. Now, what is concurrency control? Concurrency control is nothing but when multiple users are sharing the same database at the same time, it should prevent two users from editing the same data at the same time. Like for example, we have travel agents or reservation agents, and if one of the agents is booking a bus ticket for a particular passenger, and if he is assigning a seat for that passenger, then that particular seat should get blocked and no other agents should be able to access or book that seat for any other passenger. And that is what we call as concurrency control. These kind of applications that require concurrency control are called as OLTP or online transaction processing, and it is a major part of database application. DBMS must enforce or must ensure several transaction properties, and here transaction means program under execution. So the two different transaction properties are isolation and atomicity. Now, what is isolation? Like we already discussed in the previous example, if one agent assigns a seat to a particular passenger, then that seat is blocked or it is isolated from other agents. So that is one of the transaction properties that DBMS must enforce. The next property is atomicity, where DBMS should ensure that the transaction is executed completely or none at all. Now, when an agent is assigned a seat for a passenger, and if the transaction is stuck midway or if it is incomplete, then that seat has to be released for other agents to access. So either the transaction should be executed completely or none at all. So this is sharing of data and multi-user transaction processing. With this, we come to the end of this video. Hope you all have understood the main characteristics of DBMS approach. Thank you.